Today we are going to graph piecewise defined functions. So our objective is to write, graph, and use piecewise defined functions to solve problems. So first we have to know what a piecewise defined function is. So it is a function, and a reminder that again, a function, every input has only one output. So again, every input has only one output. So again, a function is a rule that matches inputs to outputs, and every input can have only one output. So that's the definition of a function again. So a piecewise defined function is a function that has different rules for different intervals of its domain. Okay, meaning that you can't just use, let's say, for example, a rule would be multiplying by 3. So we would write it as like 3 times x. So far, our functions have been, that's the rule for the entire function. Now, a piecewise defined function is going to have different rules for different parts of the function. Okay, so we're going to look at an example that could easily be modeled using a piecewise defined function. So here we have in this first task, a deep farmhouse sink is slowly being filled with water at a rate of 2 gallons per minute. So every minute, 2 more gallons is getting put into this sink. After 4 minutes, the stopper accidentally comes loose, and over the next 2 minutes, the volume decreases by 15 quarts. Once the stopper is properly put back in, water fills the sink at a rate of 3 gallons per minute to fill the sink to a capacity of 22 gallons. Okay, so really what we have happening is for this first bit, okay, it's being filled with water at a rate of 2 gallons per minute. So the amount of water in the sink is going up for those first 4 minutes. And then after 4 minutes for this next bit, the volume decreases. So now the water level is going down. So what was an increasing function at first is now a decreasing function. And then we go back to increasing again. Water fills the sink at a rate of 3 gallons per minute. So now we're going to increasing again. So for this pink bit, it's an increasing function. Okay. For the green bit here, it's decreasing because water level is going down. And then for the orange bit, it's increasing again. Okay. So this function cannot be defined in just one piece because there's different chunks to it. So for part A, explain why the situation can be modeled using a piecewise defined function because different things are happening over different parts of the domain. Okay, so different things are happening over different parts of the domain. Okay. So, and we can look, they actually give us a nice graph for this for the pink part. Here's the pink part of the graph where this is increasing at a rate of 2 gallons per minute. So that 2 gallons per minute would be the slope. So for this first bit, it's going to have a slope of 2 because it's going up by 2 over 1 up. Okay, it's going up by 2 over 1. Again, look at our scale. We have to be very careful. These are counting by 1s. These are counting by 10s. Okay, so it's going up 2 over 1 for each of that slope there. But then here we're decreasing. So this next bit here, so for those first 4 minutes, and then for the next 2 minutes here, we're decreasing. So there's the green part of the graph. Okay, and then here's the orange part of the graph where we're filling it back up again. Okay. Okay, and then here's some bits that we didn't discuss in the problem here. But here, the sink is just at capacity. So I don't know, maybe for that part D that they have labeled as D, we're doing the dishes. So we're not putting water in or taking water out. The sink's just sitting with that amount of water in it. And we can actually calculate the amount of time it's sitting with that amount of water in it. It's sitting it from 12 minutes up to 20 minutes. So there's 8 minutes in there where the water's sitting in there. And then we have this last bit. I don't know. and orange. Here we have this last bit. Oh, we already had an orange. Blue. Okay. We have this last bit where it's decreasing, where it looks like that we'll be draining the sink. Okay. And again, we can look at the time it takes to drain the sink. Here we're going from 20 minutes over here to about 20, not quite 24, so I don't know, something around there, 20, 21, 22, not quite 23, almost 23 minutes there where it's draining. Okay. So I don't know, we can say that's 22 and a half, 20, 21, 22, that would be 23, 22.75, somewhere around there. Okay. So here they ask for the next question, what is the domain of the function? If we remember, domain is the inputs. Our inputs in this case are our time, that minute, and we go from an input of 0 minutes, all the way up to almost 23 minutes. So almost 23, I don't know, 22.75. So the domain of this would be, from 0 to 22.75 minutes. Okay. And we could also write that using interval notation, 0 less than or equal to x less than or equal to 22.75. Okay. Or we could, again, write it in words the way we wrote it in words right here. Like there's our words. I don't know what that does. There's our in words. And then here's our interval notation. So there's our domain. Now our range. So now the range is our outputs. So the range is the outputs, which in this case is the y. So now my y again is up and down right here. So how far up and down does this go? From 0 all the way up to the highest it goes is 22 gallons. So the range would be from 0 to 22, but that's in gallons. So, or we could write it using interval notation. 0 is less than or equal to, we would use y, or f of x is less than or equal to 22. Okay. So that would be our range, our outputs. Where is the graph increasing? Increasing, going up. So we want to be going up. Where is it increasing? So it's increasing on this pink section here. So from an x from 0, again, we describe it using x from 0 to 4. So it's increasing from 0 to 4 minutes. And it's also increasing on this interval here from 6 to 12 minutes and 6 to 12 minutes. That is where it's going up. What do these intervals correspond to in this situation? Well, when the water level is increasing, that would be the water levels going up, or putting water into the sink. Or the water level rising. Okay, so there we're putting water in the sink and the water level there is going up. Okay, where is the graph decreasing? Going down. It's going down on this interval from 4 to 6 minutes. Okay, and it's also decreasing when we're draining it from 20 to 22.75 minutes. And the water level at that point is going down. What do these intervals correspond to in this situation? Water level going down. Okay. Where is the graph constant? Just stays, just constant, nice and, it doesn't go up, doesn't go down. That would be this interval here from 12 to 20 minutes. What does this interval correspond to in this situation? I don't know, maybe doing the dishes? Doing the dishes, possibly? Water level not rising or falling, just staying the same. So we aren't adding water to, we're taking water out. The water level is just staying the same.